Welcome back, lab partner. This is your last lab, the last lab of the course. Because 1 week from this lab, when we post it, you have your final exam. And we're not going to do a lab in that last section of electrochemistry. It's a very short section, and then you would only have 2 days to get it done, and not the full week. And so we're not going to do that together. So we won't have that lab in that one. If we were together, we would do it, and this would be a quick lab. We'd get it done, but we won't do that for this class. All right, so anyways, so the last lab is on entropy. So you have to go to Essential Documents and get Entropy Lab. And it's a sheet of paper. It's a dry lab. If you and I were in class, some of you would want to do this before you left class, and some of you just say, no, just do it at home, because you can. You can do it at home. I'm trying to get the knot out of my, see if I can do this. I think I got it. Taking this off. I don't need my apron for this. You'll see that I have my Spaceship Earth shirt, my favorite ride ever. Love that shirt. Love that ride. All right, now the last lab on entropy, the dry lab, you get the sheet of paper, and it's going to just go through, and you have a bunch of things that you have to do. There's like 9 or 10 things that you have to do. And what you're going to be doing is you're going to be relating entropy to probability. Some of you have probably taken statistics before. Well, we're going to kind of do something with that. We're going to do some probability and statistics with rolling dice. We have 2 dice, roll dice, plural, and flipping coins. So I just put on the board behind me a table that you might want to have ready when you're getting the data for this. So when you take 2 dice and you roll them, you don't have to actually physically roll 2 dice. If you want to, sure, go ahead. Or you can do it, you can get an app on your phone and do it. Or you can just go Google roll dice app thing, and it'll do it for you 100 times, and it'll do it 100 times immediately for you and give you the results. Or you can just have some fun, roll some dice, or take some coins, flip them. Again, you can get an app for that too if you don't want to physically do it. But come on, have some fun, dive in. So for the rolling of the dice, you want to have a chart like this. Up here I put red and white. I don't know if you can see that. It's kind of faint. Yeah, it's kind of faint. Okay, whatever. Okay, but you can see. And let's say I have a red die. I put red and white because it's easier if you have 2 different color dice. It don't have to be a red and white dice. It can be whatever. It can be 2 white dice. Put a little mark on one of them. Whatever. So you roll them. We'll see the red die comes up to be a 4, and the white die comes up to be a 5. Red die 4, white die 5. Boom. Nailed it. Got one. All right, put that down. Roll again. Red die comes up to be a 6. White die comes up to be a 2. Red die 6, white die 2. Boom. Do that. And you do that 100 times. 100 times, yes, because we need good data. We need to have probability do what probability should do when you have more statistical evidence. It should fall into a pattern. It should be a pattern. It should be a percentage for how many snake eyes you get. So if you have a 1 and a 1, you get snake eyes, 1 and 1. Did you know that when you get a 6 and a 6, that's called boxcars, boxcar? Maybe you didn't know that. Most people know the snake eyes. So you can learn things. Do the same thing with flipping coins. And here I put a much easier to do, right? Only need 4 boxes. I put P for penny and N for nickel. You can flip whatever you want. Just make sure. So if I take the penny, it comes up tails, and I take the nickel, and it comes up tails. Then tails and tails. I put 1 there. If I flip the penny, it comes up heads, and I flip the nickel, it comes up tails. I put 1 there. There should be probabilities to how these things fall, and that's part of this lab exercise. Now, when it comes to entropy, entropy is referring to disorder, and over time, things become more disordered. Statistically, that's what should happen. So what you're going to have to do, and the most important question is the last question. The last question is, how do you relate entropy to probability? And I'm going to refer you to, hang on, be right back. '13th edition. Book. Let's find the entropy chapter. Oh, acids and bases, electrochemistry, entropy, nailed it. All right. let's see, where is it? I am in chapter 17. And I am going to, there it is. All right. And now the different editions are going to be different. You might have 11th edition or 12th. You might not have any editions. I mean, I don't know. Maybe some of you probably don't. But if you have the 13th edition on page 779. And if you have an older edition, it won't be exactly on that page, but you look in the entropy section, chapter 17, and it talks about, here it is, microstates and entropy. And you read that section, and that section on microstates and entropy is going to give you a big hint how to answer that last question on how does probability and entropy relate. How do they relate? Why are we flipping coins? Why are we rolling dice? What does that have to do with entropy? All right, let me just give you a little bit of a hint. If you're rolling your dice and you do it 100 times, statistically speaking, the hardest die rolls, or dice rolls, you're doing 2. Dice rolls are snake eyes, 2 1s, and boxcars, 2 6s, because you only have a 1 in a 36 chance of getting that. That means out of 100 rolls, you should get 2, actually closer to 3. The odds are you'll get 3 snake eyes and 3 boxcars in 100 rolls. If you roll 100 times and you get 37 snake eyes, you might, if that happens, you should go out and play the lottery because you have a better chance of winning the lottery than that happening. If that happens, I would suspect something. Either 1, the person's cheating, or 2, they have loaded die. Somebody's put work into the system in order for that to happen. Ooh, I just said too much. I've said too much. Said too much. All right, yeah, work into the system if that happens, because it shouldn't happen. All right, so probability-wise, you should get 2 or 3. So go ahead. You actually, this can help you in a lot of different things. If you're a gambler, you want to get into gambling? Sure, absolutely want to get into gambling. I can play some craps. Look, be a lady tonight. What's the most common roll? 2 dice. 7. Why? The most combinations. 6, 1, 1, 6, 2, 5, 5, 2, 3, 4, 4, 3. And this is the most common. You have a 16% chance of rolling a 7. That's the highest probability. So I want you to compare your rolls and your results to what actually should happen, statistical probabilities. So that'll be another thing. You might want to make a chart for that as well. Or you might want to make a chart that has dice rolls showing what's the most likely. Actually, you don't have to do a chart in that case. You just do a number probability. There are 6 combinations to give you a 7 out of 36 possible combinations of rolling dice. 6 out of 36, 16%. So you can just do it that way. But compare your numbers, your percentages, how many you roll, to what you should get, statistically speaking. When it comes to rolling, flipping coins, what are the odds that you are going to flip 4 times in a row, 2 heads? Well, there's only a head and a head. It's only 1 out of 4 combination. 4 times in a row, that's not very likely. So let's say that, for example, you do 100 rolls, flipping of the coins, and you come up with head and a head. There's only a 25% chance of that happening. When it got head-tail combination, it's a 50% chance. Tail is 25%, head is 25%. But you roll, you flip your coins, and you come up with 75% of the time you got heads. Whoa, it's weird. Something ain't right. All right, so this last lab, there's, you answer the questions. You make you do your probabilities, write out what they should be, write out what you got, you compare the two, and then check out microstates and the energy on that page. Now, if you don't have a textbook, then I would Google it. Google's your friend. Google. How are microstates and probability and entropy related? What's probability have to do with entropy? Find it. And people have written stuff on it. So you can go ahead and find that and answer that question. That is your last lab of the class. So this last lab is a dry lab. You just go ahead and get that lab sheet and start rolling, start flipping. All right, and then just answer the questions. Show me your data and answer that last question on how are those two related, probability and entropy. And that's it. All right, my partner, you've been awesome. I hope when you're rolling these coins or flipping the dice, no, where's that? Flipping the coins, rolling the dice, that you're wearing goggles and apron, okay? You want to get one in the eye. because then it's all fun and games, so somebody loses an eye because you were flipping coins too hard. Okay? All right, lab partner. Oh, that hurt. Okay, we'll see you soon. You're my favorite.